Now we're going to talk about a topic called parameterized tests. And it's basically running multiple test scenarios. So you have one test and you're just changing some of the inputs, and we'll talk about that in a minute. So the first thing to ask, is there something that you don't like about the test that you wrote? And I'm talking about the test for the previous exercise, so the test for the temperature converter. Is there something in there that we should refactor? And my guess is, if you look at your tests, depending on how you created them, there's probably some duplicated code. My guess is all the tests look exactly the same, and the only thing that changes are the inputs and the outputs. So you're changing some constants. And there is a better way to do that. Now, before we talk about the better way to do that, let's just talk in general about what makes for good automated tests. So they should be automated and repeatable. So that means that we should be able to run them quickly and easily. And repeatable means we should always get the same result unless we actually change the test code itself. So if it depends on the time of day, or it depends on some external thing, like, oh, it needs access to this piece of hardware or this network connection or something, that's not repeatable. It should be easy to implement. So we don't want to spend all our time writing tests. Our main goal is to write production code. The tests are kind of an aid to do that, but we don't want to invest a ton of time in our aid. It should be relevant tomorrow. So we want to test things that, not just for right now, but we want to make it something that we can rerun those tests tomorrow and the next day, and it still gives us useful information. You should be able to run at the push of a button. In LUnit, it's pretty easy to run the test. There's a button on the project window. There's a tools menu entry. There's a quick drop shortcut. The test should be quick. Unit tests in LabVIEW are not quite as quick as other environments. If you use Python and PyCharm, PyCharm's pretty quick. You got a keyboard shortcut, and usually by the time I release the keyboard shortcut, it's done running. LabVIEW's not quite that quick, but my rule of thumb is I like my test to be done in under 10 seconds or something, if I can help it. And that's like a lot of tests for a large project. It should be consistent in results, right? So it always returns the same results unless you change something. It should have full control of the unit under test. The unit under test is a software that you're testing. So the test should be able to control all the inputs and outputs, and we'll talk a little bit more about that. It should be fully isolated, so all the tests should run independently of any other tests. If you're used to doing like factory acceptance test or site acceptance test, you might have a test where you come in and you say, hey, set this input to this, set this input to that, right? And you go through and you set all the inputs, and then there's another step that says verify something, and each step depends on the previous steps having passed. We want to avoid doing that with unit tests in particular, because most unit test frameworks don't guarantee the order in which our tests run. So we don't want our tests to be dependent on what else is run before it. As an example, if you have one test that tests writing something to the database, and then the next test reads that same thing, if the write failed, then the read would also fail. We don't want that. Or if you change the order and you tried to read before it wrote, the read would also fail. So that's what we're trying to avoid. And one of the last ones is when a test fails, we want it to be very easy to detect what was expected and determine how to pinpoint the problem. So we want to be able to just look at the test result and immediately go in our head, oh, I see what the problem is. And the closer we can get to that, the better. As opposed to like a large end-to-end test. So if I think about it, say, you have a system and you're doing like a factory acceptance test, right? I toggle an input. Well, some output way over there is supposed to toggle. It doesn't. Well, where's the problem? Is the problem in the wiring? On the input? Is it the input card? Is the software looking at the wrong channel? Is the software not calculating the alarm correctly that's supposed to trigger the thing over there? Did it not trigger it? Is that thing not wired up correctly? Right? There's multiple points of failure along there. And what we want to do with our unit test is isolate. So we want to just say, hey, if the input reads this, we should set the output to this. And it's very simple. And we're trying to eliminate as many of the variables as we can. And this comes from a book, actually, The Art of Unit Testing by Roy Osherov. Great book. Really like it. There's a new edition coming out. I think he's on the 3rd or 4th edition. So really good book. Highly recommend.